Everyone, this is question 3A of the practice exam. This question, you told you have 1 mole of air and it is undergoing 2 different processes, so through 3 different stages, starting at A, going to B, and then to C. And you're told what those processes are, and you want to find pressure, temperature, and volume for each of those stages. So you get some of the information right out of the question. For A and C, you have the pressure and the temperature. That's all you have though. But to figure out how to get the rest of these variables in each case. So the first thing you get though is the volume for A and C, just using ideal gas law. So if we're going to go for VA, it's going to be nRTA over PA. And you really just have to watch out for your units in this case here. So we have 1 mole. Now here you have to decide whether you're going to be using pascals and meter cubed, or whether you're going to be using atmospheres and liters. In this case here, I've decided to use the Pascal meter cubed. So that means we have to transform our bar into pascals. You can keep this the same, and we're going to use as an R 8.314 joules per mole Kelvin, because the joule is a Pascal meter cubed. So there's your pressure and there's your volume. So our temperature is 298 Kelvin. And all of this over our pressure, 1 bar is equal to 1 times 10 to the 5 pascals. So the volume that you end up with in this case here, which I won't write down there, I'll just write the answer right up in here, is 0.0248 meter cubed. You're going to go ahead and do the same thing now for C, just instead of using 1 bar, it's 5, so it's going to be 5 times 10 to the 5 pascals, and it's the same temperature. So the value you get for that one, 0.00496 meter cubed. Could have also given your answers in liters and atmospheres as well. Just keep it consistent, your unit set, and make sure it's correct. So now we need to find out for B. We're not given any information about B, but we're given some information regarding how we get to B from A for 1. So in this case here, it says we're compressing it at a constant pressure. That's telling us right away that our pressure at B is going to be the same as it was at A. So our pressure is 1 bar. Now we can maybe get some information in looking at B to C. So B to C, we're told that that is being heated at a constant volume. So our volume is going to be constant from C. That means our volume in this case is 0.00496 meter cubed. So now the only thing we're missing is temperature. And again, you would just be getting that using your ideal gas law. So, oops, not A, we're looking for B in this case here. So pressure B times volume B over nR. And as long as you have correct units in this case, so stick with, when we're switching this into pascals, it's going to be 1 times 10 to the 5 pascals. You have this in meters cubed already, using 8.314, and the temperature should be 59.6 Kelvin.